Today I want to deliver a class related to the chemical equation, or we can say chemical reaction, how to write chemical equation. And I want to give you guarantee that if you listen to me and if you follow my instruction properly, 100% you'll be able to write a chemical reaction and you can balance that chemical reaction. Okay, for this, first we have to remember the valency of elements, number one. And we have to remember, secondly, we have to remember the radical, its formula and its valency. And then we'll be able to write molecular formula. And when we become able to write molecular formula, then only we'll be able to write chemical reaction. That's why I want to start with valency of elements first. We don't have to remember valency of all 118 elements, but the valency of those elements which are used in the chemical reaction, which comes in the chemical reaction frequently. What are they? You have to remember few, I think 20 or 25 only. Valency 1, hydrogen, lithium, sodium, potassium, fluorine, chlorine, bromine, iodine, silver. If you remember this, it will be enough. Then valency 2, the elements having valency 2, you have to remember oxygen, sulfur, calcium, magnesium, zinc, copper, iron, mercury, cobalt. These are few. Okay, number 3, valency 3. This is nitrogen and aluminium. You have to remember these two. And valency 4. The elements having valency 4. Carbon, silicon. Valency 5. Phosphorus. Now I want to tell you one another matter also, that is valency 6. There is an element which has variable valency, sulfur. Now sulfur is repeated here. Sulfur is repeated here. Here it is present, sulfur valency 2. Okay, it means some of the elements have variable valency. Now we have to remember that also. First I want to point out the metals. Look at this, lithium, sodium, potassium are metal, silver is metal, and the same way calcium, magnesium, zinc, copper, iron, mercury are metal, and aluminium also metal, other are not metal. Now there are some metals which have variable valency. I want to mention them first. What are they? Just for example, copper has sometimes valency 1 also. This we have to remember, but most of the time its valency is 2. Sometimes we have to use valency 1 also. Mercury is valency sometimes 1. I am taking these two in the ring because this is occasionally, sometimes we have to use 1 and 2 valency. 1 valency of these two. Okay, now there are other also, just like nitrogen, its valency is normally 3. It has valency 5 also. And sulfur is valency, normally its valency is 2. Sometimes its valency is 4 also, and sometimes 6 also. You have seen here. Okay, we have to remember this. Beside this, sometimes in the molecular formula, what is written? OUS, OS, and EC are also written for the metals. Just for example, some metal. Just for example, metal, just copper. If cuprous is told, then we have to use valency 1. Here it is. And if cupric is told, we have to use valency 2. In the same way, sometimes mercury also. Mercurous is if told, we are using valency 1. If mercuric is told, valency 2. In the same way, aurous, valency 1, auric, valency 3, about the gold. And there are other also. One is lead. Lead is plumbous, valency 2, plumbic valency 4. And iron also, this is most important, ferrous, ferric valency 2 and 3. Minimum valency, Os represents less valency, Ic represents more valency. Now after this much understanding, now you will be able to write, you will be able to start the chemical reaction. Here iron valency 3 also, and this lead valency 4 also. Normally lead has valency 2. Okay, this is the frame of what? The elements which we use in the chemical reaction frequently, which comes in the book and other places, came in the chemical reaction frequently. We have to remember their symbols and we have to remember their valency. This way, just for example, if you are told to say valency sodium Na, valency 1, copper Cu, valency 2, nitrogen N, valency 3, lead Pb valency 2. Sometimes if someone says lead has only valency 2, then you can say that it has valency 4 also, and most of the time it has valency 2. The same way magnesium Mg valency 2, potassium K valency 1, aluminum Al valency 3. We have to be fluent in our memory. This all, if not remembered, we will not be able to write molecular formula of the compound, and if we cannot write molecular formula, then we cannot write chemical equation also. This is the starting point. We have to remember this first, and then now second part I want to tell you. Second also, you have to remember the formula and valency of radical also. Now secondly, what I am saying, formula and valency of radical. Okay, formula and valency of radical, just like this. Sulfate, its formula is SO4, valency is 2. Sulfite, its formula is SO3, valency 2. Nitrate, NO3, valency 1. Nitrite, NO2, valency 1. Hydroxide, hydroxide is OH and is valency 1. Ammonium, NH4, its valency is 1. Bicarbonate, now I am talking about bicarbonate also. Bicarbonate means hydrogen carbonate. Bicarbonate, HCO3, valency 1. But carbonate, valency is 2. Bisulfate, HSO4, valency 1. And bisulfite, HSO3, valency 1. Chlorate, ClO3, its valency is 1. You have to remember this. These are the radicals. Radical means group of atoms which behaves as a single unit in the chemical reaction, and they are like element, they have valency. They are the like element, they have valency, and they have definite combining capacity, and this is the combining capacity, valency. This is the formula, and these are the radicals. We have to remember they comes frequently in the chemical reaction. If we remember all these, then we have to be clear about some other matter also, like this. If someone says chloride, you have to remember that this is chlorine. Sulfide, sulfur. Nitrite means nitrogen. Oxide, means oxygen. Bromide, bromine. Hydride. Look at this, ide suffix is coming. This represents the element. If someone says iron chloride, then chlorine is combined with iron. Iron sulfide, sulfur is combined with iron. In the same way, aluminium nitride means nitrogen is combined with aluminium. This way, chloride, sulfide, nitride, oxide, bromide, this represents the elements combined. Okay. Now, after this much understanding, we'll be able to write molecular formula. Molecular formula means the smallest particle of a compound is molecule. And sometimes some of the elements also available in the form of molecule. I'll tell you about the element also. But now I want to tell you about this molecular formula of compound. If you have given certain compound in the chemical reaction in word, just like calcium chloride, then you can write easily, because you know the symbol of calcium. Previously in number 1 I told you calcium Ca. Chloride means chlorine is combined. Calcium valency 2, chlorine valency 1. Now it means what? We have to exchange the valency. Calcium valency 2 should be transferred to chlorine. Chlorine valency 1 is usually not transferred. Ca itself is 1. That's why, what is the molecular formula of calcium chloride? CaCl. In the same way, aluminium oxide, aluminium Al, oxide means O, oxygen is combined. And valency of aluminium 3 and valency of oxygen 2. That's why we have to exchange. Aluminium 3 is given to oxygen and oxygen 2 is given to, and Al2O3 is the molecular formula of the compound aluminium oxide. In the same way, sodium hydroxide, sodium Na hydroxide OS. Sodium valency 1, hydroxide valency 1, equal valency, no exchange. Thus, actually, if we remember this valency of radical and the symbol and valency of the elements, then we can write molecular formula this way. Other example also. Look at this. Ammonium phosphate. Ammonium NH4, phosphate PO4. Now, ammonium valency 1, phosphate valency 3. Here, I forgot to write phosphate, PHOSPHAT. Phosphate, PO4, its valency is 3. Okay, we have to exchange the valency. Valency of phosphate should be exchanged, should be given to ammonium. If we are giving valency to radical, then we have to put that radical in bracket, and then only we can transfer. But one valency of ammonium, we are not giving it to phosphate because PO4 itself is 1. Okay. If aluminium nitride, aluminium Al, nitride means nitrogen is combined. What it means? Aluminium element is combined with nitrogen. Nitride, NiTride. Aluminium valency 3, nitrogen valency 3. If both have equal valency, there is no exchange. Here also same, here also same. This way, now we are able to write molecular formula of the compound. There are certain name of the compound which are commercial name. We have to remember them separately in another class. I will tell you about that also. Beside that, looking at the name of the compound, now we are able to write molecular formula. Anything we can write, just magnesium hydroxide, Mg, magnesium hydroxide means OH, valency of magnesium 2, hydroxide 1. We don't have to transfer 1 to magnesium, but valency of magnesium 2 should be given here, not this way, because radicals should be kept in bracket while transferring valency. This way, we are now able to write the molecular formula of the compound. Now we can write chemical reaction. Let's start. Some of the chemical reaction I want to tell you. Look at this. But just before the chemical reaction, I want to mention another matter which is very important. Some elements, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, these elements, wherever they are, when becomes free, then two atoms share their electron, and they always forms a pair, and the pair goes in the chemical reaction. That's why if we have to write iron combines with oxygen, then we'll write iron Fe but oxygen O2, because oxygen is always available in the form of diatomic state. But iron is not in diatomic state, it is monoatomic state. Out of 118, all are not actually available in the form of this diatomic state. Few are in the form of diatomic state when they become free. And so we have to remember them while writing chemical equation. They should be written too, just like S2N2O2 F2Cl2. But other aluminium, carbon, sulfur, iron, any other, they won't be they shouldn't be written too. Just like Fe, when iron combines with oxygen, then what happens? Iron oxide, FeO. And if it is told ferric oxide means iron has maximum valency. Iron has two different valency, 2 or 3. Now ic means 3, os means 2. Ferric oxide means what? At this time, valency of iron will be 3 and oxygen is 2. And 2 of oxygen is given to iron and 3 of iron is given to oxygen. This way, we will write correct molecular formula in this combination reaction. Okay, now look at this another also, just like this. When hydrogen combines with oxygen, what they form? They form water. This is very simple. And another also, let's take another also. Aluminium when combines with nitrogen, we have to write N2. Aluminium we are writing monoatomic. These are diatomic. These diatomic elements we must remember whenever they become free. Then we have to write 2. Aluminium nitride, aluminium Am, nitride. Valency of aluminium is 3, nitrogen is 3, equal valency, no exchange. This way, all these are the example of combination reaction. What is combination reaction? The chemical reaction in which elements or compounds combine to form single compound, that is called combination or addition reaction or synthesis reaction. Now, how to balance this? I suggest you to go through the last, because we are using heat and trial method. Here oxygen is 3, here it is 2, here is odd number, here we have even number. If it is so, then it is better to put 2 in front of the odd number and make it even. We never write any number at the bottom part while balancing, here, because at the bottom part, if the element is diatomic, then we will write 2. And in the bottom part, when we exchange the valency, and exchange of valency may give some number that will come. Otherwise, while balancing the equation, we have to put the number just in front of that element or compound. That's why here it is 2, here it is 3. I mean to say, I want to make them equal, and it is possible only if odd number is converted into even number. That's why 2 is taken here. 3 2s are 6. Now if we take here 3 2s are 6, oxygen is balanced. Now it's turn of iron. 2 2s are 4. Here if we write 4, now this equation is balanced. This is called balanced chemical equation. Okay, now look at this second. Oxygen here 1, here it is 2. This is odd. If we put here 2, then oxygen is balanced both the side. Now hydrogen 2 2s are 4. If we take here 2, it's balanced. Now aluminium and nitrogen, aluminium nitride. Nitrogen here 1, here 2. If we take here 2, then nitrogen balance, aluminium is 2, here 2. This way we can write chemical equation and we can balance it. This was about combination reaction. Let's take some example of decomposition reaction. Decomposition reaction is just opposite of the combination reaction. We can define this way: when a compound splits up into 2 or more than 2 elements or other compound, then that is called decomposition reaction, or sometimes dissociation is also told. Okay, we can take example, but for this sometimes we have to remember something. Just like in the preparation of oxygen gas, we are using potassium chlorate. Potassium chlorate is heated at high temperature. Look at this, K, potassium K, chlorate means ClO3, potassium valency 1, chlorate valency 1. Previously I told this. and equal valency, no exchange. When it is heated, we have to remember that it forms potassium chloride, potassium 1 valency, chlorine 1 valency, equal valency, no exchange, and oxygen gas produces. Oxygen when becomes 3 diatomic. Oxygen here 2, here it is 3. If we take here 2, then 3 2 is 6, it becomes even. And if we take here 3, 3 2 is 6, now it is balanced. Now it's turn of chlorine, chlorine 1, chlorine 2. That's why we have to take here 2. And potassium 2, potassium 2. This is balanced chemical equation. This is decomposition reaction. There are some decomposition reaction which may be previously balanced like this also. Look at this. Calcium carbonate, when heated at high temperature, then it converts to calcium oxide and carbon dioxide gas. This is one of the method of preparation of carbon dioxide gas in industrial scale. Limestone. Actually, calcium carbonate has the 3 different form. One is it is available in the form of marble, which is hard calcium carbonate, and limestone, which is softer than marble, and chalk, which is more soft than that of the other. And this limestone is heated at high temperature and decomposed into calcium oxide and carbon dioxide, and this carbon dioxide is collected and supplied in industrial purpose, for industrial purpose. This is balanced chemical equation. We don't have to do anything. Oxygen 2, oxygen 1, 3, here 3, and carbon 1, carbon 1, calcium 1, calcium 1. This way we can write decomposition reaction also. Now let's talk about displacement reaction, some of the reaction. Normally when a metal reacts with acid, then what happens? Let's take one metal and acid. Let's say when zinc reacts with hydrochloric acid, this is hydrochloric acid, but this is a commercial name. We have to remember differently. I'll tell you in another class what sort of compound have commercial name, and looking at that name we cannot write molecular formula. Those compounds, the molecular formula of those compounds should be remembered directly, and we have to write them directly. Zinc when reacts with sulfuric acid, what happens? Metal when reacts with acid, metal displaces the hydrogen of the acid and forms salt. Zinc displaces hydrogen and it forms zinc chloride. Zinc valency 2, chlorine valency 1, which we don't have to transfer, and zinc valency 2 is given to this. And displace hydrogen when it becomes 3. I told you this is diatomic element. Yes. Now how to balance? Hydrogen 2, hydrogen 1. If I take here 2, hydrogen balance, chlorine 2 balance, zinc 1, zinc 1. It's okay. In the same way we take another also. Look at this. Aluminium when reacts with sulfuric acid, metal is reacting with acid. When metal reacts with acid, if reaction takes place, normally what happens? Metal displaces the hydrogen from acid to form a salt. Look at this. Aluminium displaces hydrogen and what formed? AlSO4. Aluminium valency 3, sulfate valency 2. Sulfate valency 2 is given to aluminium. Aluminium valency 3 is given to sulfate, and we have to keep this radical in bracket. And hydrogen is displaced, that's why hydrogen separates this way. Okay, now how to balance this? Hydrogen 2, hydrogen 3 seems to be okay. Sulfate 3, here sulfate 1, it's not balanced, that's why if we take here 3, then sulfate becomes 3, here sulfate 3, okay, but hydrogen is not balanced now. Hydrogen 2, 3 2 is 6, if we take here 3, 3 2 is 6, okay. Now aluminium 2, if we take here 2, then we will be able to balance this also. This way, displacement reaction or chemical reaction in which an element of a compound is displaced by another element or radical, then the reaction is called displacement reaction. This type of reaction also we can write. Now let's talk about acid-base reaction. Acid and base have completely different property. One, they have just the opposite property. That's why whenever they react with each other, they destroy each other's property and forms neutral compound, that is salt and water. We have to remember this. Acid when reacts with base, then what happens? Salt forms and water forms, not other than salt and water. Now let's take example. Sodium hydroxide, metallic hydroxide are bases. If you are told or not, I don't know. But metallic oxide, metallic hydroxide are bases. This is sodium metal. I gave you idea of metal also in the first when I started the this class. Then I told I gave mark on the metal also. That's why it will be better to have knowledge of metal also. I mean to say identity of metal. If you recognize a metal, then it will be easier for you. Sodium hydroxide, calcium hydroxide, magnesium hydroxide, potassium hydroxide, metallic hydroxide, or metallic oxide, sodium oxide, potassium oxide, calcium oxide, magnesium oxide, zinc oxide, any metallic hydroxide and metallic oxides are bases. And acid is identified as what? A compound having hydrogen, and when it is placed in liquid, then hydrogen ion, it gives hydrogen ion. They are sulfuric acid, nitric acid, hydrochloric acid, and other acids are also there, oxalic acid, acetic acid, etc. This is metallic hydroxide base. If it reacts with nitric acid, or let's say sulfuric acid, H2SO4, then what happens? Salt forms and water forms. How salt forms? Hydrogen of acid is displaced by the metallic part of base. It means metallic part is sodium, and sodium displaces hydrogen, then what it forms? NaSO4, sodium valency 1, sulfate valency 2, and that's why we have to put here 2. And plus another product is water. This way we are writing. Now we have to balance this. Oxygen 1, I am not counting this oxygen. Why? Because here is sulfate and here also sulfate. Left hand side, right hand side, both sides have sulfate. That's why this oxygen is not added with this. And sulfate I will count differently. Oxygen 1, here oxygen 1. Hydrogen 2, and here hydrogen 2 and 1 3. That's why here we have odd number. It can be converted to even number by taking 2 here. 2 plus 2, 4. If we take here 2, it becomes 4. Now oxygen is okay or not? Oxygen 2. Yes, it is okay. Now sulfate 1. Hydrogen also okay. Oxygen also balanced. Sulfate 1, sodium 2, balanced chemical equation. Okay, we can take other also just like this. Nitric acid, if reacts with aluminium hydroxide, let's say aluminium hydroxide. Aluminium hydroxide is aluminium valency 3, hydroxide 1. That's why I have to give you 3. Plus, now let's take another nitric acid, HNO3. HNO3. We have to remember this properly. I'll tell you in another class. The commercial name nitric acid, not hydrogen nitrate. Okay. Now how they react with each other? This is base, metallic hydroxide. This is acid. And when it reacts with each other, then salt and water forms. How salt forms? Aluminium displaces hydrogen. Then aluminium nitrate forms. AlNO3. Aluminium valency 3, nitrate valency 1. That's why we have to give here 3. And plus another product is water, because when acid reacts with base, they always form salt and water. Okay, now let's count. This oxygen 1. This oxygen I am not counting because nitrate is present in both the side. I will count nitrate. Oxygen 1, oxygen here 3. That's why it's better to have 3 here. Now oxygen is balanced. Now storm of hydrogen, 3 2s are 6. Now look at this, here it is 3. If we take here 3, then 3 plus 3 becomes 6. Hydrogen balance. Nitrate 3, okay. Aluminium 1, aluminium 1, okay. This is acid-base reaction. When acid reacts with base, it forms neutral compound salt and water, and the reaction is called acid-base reaction. Okay, this way I started with the symbol and valency of element, and then I told you about formula and valency of radicals. After these two, we'll be able to write molecular formula, and when we'll be able to write molecular formula, we'll be able to write chemical reaction also. But we have to remember that some elements are diatomic. We have to write them like this, not S2, not N2, this way, and we'll be able to write the chemical equation. I told you 4 basic types of equation, combination, decomposition, displacement, and acid-base reaction. How do you feel this class? I don't know. I tried to give you a complete idea how to start writing the chemical equation. I think it helped you a lot if you remember all this. Okay, this much for today. Next time I'll come with another chemical reaction.